And now we are heading into our first topic section, talking about the innovative asset management processes. And with us is the head of research and development of the Berliner Wasserbetriebe, Regina Gnirss. A warm welcome also to you, Ms. Gnirss.
Yeah, thanks. Thank you from here from Berlin.
From Berlin to Berlin. The stage is yours.
Yeah, so I'm waiting on my presentation. I hope it's not Claudia's. Yeah, very good. So thanks for the kind introduction. Yeah, I think I will begin my talk by presenting the key figures of the Berliner Wasserbetriebe and the motivation for asset management. The sewer inspection and the workflow will be explained, but then I will show that we had the innovation reach the water sector by working together in the research field with the operators, and I conclude in the end. So Berliner Wasserbetriebe is one of the largest and oldest public utility in Europe. We operate 9 waterworks. We operate 6 wastewater treatment plants and serve 3.7 million inhabitants in Berlin. We will provide drinking water 220 million cubic meters per year, which fills up the Olympic Stadium. And our network in the drinking water part is nearly 7,800 kilometers. The network, the sewer network, even corresponds of a distance of 9,500 kilometers from Berlin to Tokyo. So the investment, we just learned there are a lot of new fields we have to fulfill from the European Union. So we have the trace organic removal. You see the increases here up to 400 million euros. We have to fulfill the Water Framework Directive, and we built a new sewage plant, a sewage incineration plant. But however, in light green, you see the sewer and pressure pipes investment, which is very stable with 70 million euros. And that's the intergeneration contract. Yeah, we have to look on this investment to keep it in a good shape. So the combined sewer is in the inner part of Berlin, about 25% of the area. However, in the outside, we have the separate sewer and separate stormwater. Only 96% are not accessible. So to work on this network, we need some inspection tools to go into the sewer system. And if we want to inspect the whole network, we need, if we assume we want to do that in 15 years, we need 640 kilometers per day. So that's quite a lot of things we do. The directives we can follow are the European directive and the national directive. And if you see how it corresponds with our expertise, we are included in these working groups. We gave our knowledge, and the research already goes into this working group results. In the moment, there is inspection, how mainly the rehabilitation is an important issue, but also in 2008 already, there starts a new group also with people from the Berliner Wasserbetriebe to look on the sustainability of rehabilitation measures. However, this asset management costs us a high personnel and equipment amount because it's really a manual process. We use here videos. The quality just also in the beginning was quite pure. We have high variation if we look in the inspection classes, damage classes. The standardization given in these working directives are rough. And so if you have the different operators doing this, it's subjective, it's monotone, and also a tiring process. And if you do evaluation, you find that more than 50% is in different inspection classes, and only 16% is about to be inspected in the same class and in the same protocol. So that's a high potential to have a reliable, identical inspection class identification which would be less time and cost consuming. What people do not know is that there already is a lot of digitalization going on in sewer inspection. We use robots from the first time on in the 18th. We have trenchless technologies developed with the small and medium-sized companies. And yeah, we have here, for example, the high pressure rinsing machines. We have the cutting milling machines. We have an example of a unique camera. So there's a lot of tools where we are in a digital world, where we have a lot of data. But however, this is also a burden because you have to store this data. In the moment we are running to the 120 terabytes. And due to the long-term developments, you also have data sets which are not always consistent. So here you will learn in the video how the prognosis of aging processes in sewer systems is going on if you do nothing.
Like all buildings, sewer pipes also age, meaning that they crack, corrode, or even collapse. The condition of the sewer pipes in Berlin is periodically inspected with special cameras. However, this is very time-consuming and expensive. Now we come into play. We take these inspection results and feed them into mathematical models. They calculate not only the current state of the sewer pipes, they also take a look into the future and simulate the development of the sewer system for different investment scenarios.
Yeah, and if you like to apply for a job, I will show you what the operators are doing. That's a sewer without a damage. Sorry. Yeah, it just goes through. And here you have an innovation rehabilitation method where you can go through. You see the pipe. A flexible resin impregnate tube is installed into an existing pipe. Oh, the videos are not moving, okay. And it's expanded to fit in the existing pipe and then cured with UV light to place and to become hard in the old pipe. And if you look through, you have the intersection to connect very good to the manholes or to the intersection, so to avoid weak points. Yeah, that was not the whole impression. However, yeah, we can go to the next slide, please. I think it's not, yeah, now we have it, thanks. So if you put that all together, you have the overall workflow where you have the inspection. We are partly digital, we are partly analog, and so we have the manual damage detection and annotation going on right on the truck, on site. For the other part, it's done later on. We use software, and there are different software companies on Blaze to use, and we then have the storage in our database. So where is the possibility to find more innovation? I think you have to help me. It's not moving anymore. Yeah, okay, thanks. And if you look the whole day through the pipe, so what will you find? You find cracks, you find defective connections, the green part, you find roots, that's not a high number with 11%, you find some offset joints, and you have corrosion, which is severe in Berlin due to the sulfur production. If you look on the inspection classes, you have a distribution length of 9,500, and you see that you have about 20% where you have to repair immediately. You have the possibility to repair or to rehabilitate. I gave you one example. However, if you inspect and you see also a part where you do not have to take action, which is about 30%, and the idea was now the machine could do the inspection. When you have this inspection done, it's important that you really get the data into your in your database. You see here just the sign of one unit. The damage must be designed for this unit. You get 35 attributes with it. So it must be very, very precise what you do. We use the Nova Candice and Tiffany to get the damage class reported. If you want to know how innovative we are working, we have brought today the lecture of Matthias Riegel about SEMA Berlin, where we not only use our own parameters to have a prediction about the deterioration factors. However, we connect this data with some environmental data from the Senate. I think that's quite challenging to really have a sustainable database. You see here the number shrinks already from 250 to 140. We are getting better now in the past. And if you compare the different projects we are running on, you first have to do with Otsuka, where Daniel Sauter will go into more detail. The inspection finalized on a higher quality, that could be a good goal. Even 3D is in discussion. You have comparable, consistent database, that would be a nice goal. And we dream from an artificial intelligence, which does the automatic damage detection right from the picture. And the viewer, so if our kids play around with some games, we want to have gamification for our operators to have a better workload to do. So for the SEMA Berlin project, we have the artificial intelligence for sensitive analysis. I've shown you the parameters we should take into account. However, we want to have the short-term rehabilitation and construction on a single sewer reach based on all these factors. And we would also like to have the long-term investment strategy related to different scenarios so that you really can play around how to spend the 70 million euros in a better way and to look on district and defect classes in the same way. So here you see some examples from the project Otsuka, just the re-engineering on the left side, the builders on the top, not so shiny. On the bottom, you could see much better the problems with the offset joint. You could better see the corrosion. On the right side, you see the bounding box labeling, which we use to find the damages, which works. However, we are still not facing the whole goal we had in the beginning of the project, but you will hear that later on. However, we learned from Ms. Kastel-Exner that there are barriers when we do innovation. And I think I showed you that if you do the project together with the operators, you will really end on the desk or in the operating part. So here you see the screenshot. I don't explain the details that will be done from the speakers coming next, but you see the action taking place even during the project, and we get feedback from the operators, and we have a good result to bring the research work into the praxis. So I would like to conclude with asset management has high investment costs, and therefore we have this intergeneration contract. The high potential for digitalization, we would not say to have a total automatic system, but an assistance system where you really connect the artificial intelligence with the experience of our operators is the best story. And long-term tradition for R&D at Berliner Wasserbetriebe shows that we have good results, and funding enables innovation and collaboration with scientists and small and medium-sized enterprises. And the test implementation at Berliner Wasserbetriebe also occurred during the project, which is a good success and avoids the barriers where we often had complaints from the European Communion, what we heard before. Okay, thanks for your attention, and I hope I was not too fast.